Hi there, my name is Mitch Harlabidis, and in this video we will continue working with one of the exercises I have prepared on the practice workbook on exponential functions, which can prepare you to understand perfectly the 2.9 subtopic of the analysis and approaches standard level content. This will be an exercise on level 2, which is titled by Exponential Models with Asymptotes. Here we go. The number of fish in a lake, denoted by F, decreases exponentially due to pollution. The population can be modeled by F equals 5,000 multiplied by 0.92 to the power of t plus 800, where t is the number of weeks since pollution was detected. This is important because one of my variables would be time, but measured in weeks. And obviously, the second one would have been F, which is the population of fish. Find the initial fish population, a typical classical exercise which might always be there just for 1 mark. Find the initial fish population means in the beginning of the experiment. So when t was equal to 0. We could do that either by GDC. Here, since we refer to the analysis and approaches, we can easily do that by hand as well. F of 0 would be 5,000 times 0.92 to the power of 0 plus 800. Remember that anything to the power of 0 is always equal to 1. So we end up with 5,000 times 1, which is 5,000, plus another 800. So 5,800 what? Fish. Calculate the population after 10 weeks. T is measured in weeks. We need the population after 10 weeks. So we need to find the value of F when T is 10. This means that we will go on the calculator, we will use a calculator where we will go on the given equation, and instead of T, we'll substitute 10. F of 10 is 5,000 multiplied by 0.92 to the power of 10 plus 800. Let me go to my calculator. Times 0.92 to the power of 10 plus 800. That originally would be equal to 2,971.9 and so on. But remember that when we are talking about live beings, we have to round them to the ones that would actually exist. 2,971 exists, but the 0.9 doesn't. So my answer would be that there will be 2,971 fish after 10 weeks. Let's move to C. Determine the time, so we need time for the population to decrease to 2,000 fish. So for F to become 2,000. I'll take this info and now I'll plug them in the original equation. So 2,000 equals to 5,000 times 0.92 to the power of t plus 800. And I will lead all that to the solvent. Option calc solvent. 2,000 equals to 5,000 multiplied by 0.92 to the power of t plus 800. 800 except ignore this exit. So t is 17.11548,115. It's time, so I could either leave it like that, it's the exact value, or follow the default rounding system of the IB and round it in 3 significant, which in this case would have been 17.1. Don't forget to use units, 17.1 weeks. And finally, state the minimum population the fish will approach according to this model. Remember that sometimes, basically always, the exponential models have a horizontal asymptote. This means that they have a line that they will constantly get closer and closer and closer at without ever intersecting. And this is exactly what D suggests. Here, we know that the horizontal asymptote is always the value left by itself. So it's the 800. This means that my population started from 5,000, it keeps decreasing, 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 but since the horizontal asymptote is 800, it will keep getting closer and closer and closer and closer and closer to this number without ever succeeding to get on this number. So the minimum population the fish will approach according to this model would be 800, but if we want to be a bit smarter than that, they will never be able to be exactly 800. So the minimum that they could get, in fact, would be 801. Although they would reach 800, the minimum they can actually be is, oh no, let's leave it 800 here. And that would be all. In case you liked this video and the others and the ones that will follow, don't forget to like and subscribe. If you still find yourself having difficulties on what we mentioned on this video, you are always welcome to leave a comment in the section below. As always, thank you for watching.